Warm greetings. Have a pleasant day to all. In this module, let me explain the basic details behind the crystal structure. All we know that solid is one of the four fundamental states of matter, the others being liquid, gas and plasma. The molecules in a solid are closely packed together and contain the least amount of kinetic energy. Solids mainly classified into two types. The first one is crystalline solids. Crystalline solids are also called as crystals. Here the atoms or molecules are arranged in regular periodic manner. The other kind of solid is that amorphous solids. It is also called as non-crystalline solids. Here they have no regular structure and in which the molecule is the basic structural solid. Crystalline solids. In crystalline solids, the particles are arranged in periodic manner, hence resulting in a definite shape. The crystalline solids have directional properties and therefore they are called anisotropic substances. They are anisotropic in nature. That is, the magnitude of physical properties is different along different directions of the crystal. Moreover, when we cut the crystalline solids with a sharp edge, the two new holes appeared with some smooth surfaces. Examples of crystalline solids. Crystalline solids may be either metallic crystals or non-metallic crystals. For example, copper, silver, aluminium, tungsten, sodium chloride, diamond, etc. In non-crystalline solids, the particles are not arranged in any specific manner. Here the solids have no directional properties and therefore they are called isotropic substances. That is, the magnitude of the physical properties is same along with all directions of the solid. Moreover, when we cut the non-crystalline solids, the two new resulting holes will have some irregular surfaces. Examples for non-crystalline solids: glass, gels, etc. An amorphous structure does not generally possess elasticity, but it only possesses plastic nature. Now let us see the fundamental definitions regarding crystal structure, such as crystal lattice, unit cell, crystal structure, then 7 classes of crystal system. First one, crystal lattice. A crystal lattice is nothing but it consists of array of points in 3-dimensional space in which every point has surroundings identical to that of every other point. Here is the example. It is the space lattice. Here we see that every point has surroundings identical to that of every other point within that array system. Unit cell. The unit cell is the smallest block or geometric figure from which the entire crystal is built up by the repetition in 3-dimension system. So it is the smallest unit and is repeated in space indefinite times. It generates the space lattice. Here is the space lattice and here is the unit cell. Also, the unit cell shows the locations of lattice points repeating in all directions. Here is the lattice points. Lattice points is nothing but the position of atoms or molecules inside the crystal system. The next fundamental factor behind the crystal system is that basis. Basis is the group of atoms or molecules identical in composition. It also referred as pattern. It provides the information about the number of atoms per lattice point, types, orientation and distance of separation between the atoms. So in general we say that lattice plus basis gives the crystal structure of the system. Next comes the lattice parameters of an unit cell. The first one is that crystallographic axis. It is the line drawn parallel to the line of intersection of any three faces of the unit cell which do not lie on the same plane. That is referred to as crystallographic axis. The next one is that primitives. The intercepts A, B and C defines the dimensions of an unit cell. The unit cell formed by the primitives A, B and C are referred to as primitive cell. In a primitive cell, there is only one lattice point is present. The next one is interfacial angle. It is the angle between the three crystallographic axes, that is alpha, beta and gamma. Crystal systems can be arranged in 7 different ways depending on the relative lengths and directions of the axis of symmetry. They are triclinic system and monoclinic system, orthorhombic system, trigonal system, hexagonal system, tetragonal system and finally the cubic system. Here is the respective pictures for that 7 classes of crystals. Hence, with different stacking arrangements, it results in 7 different crystal systems. They are cubic, tetragonal, orthorhombic, monoclinic, triclinic, trigonal and hexagonal. Its respective unit vector and angles are shown in the table. The space lattices formed by unit cells are marked by the symbols like P, I, F and C. P represents primitive lattice and I represents body center lattice, F represents face center lattice and C represents base center lattice. Moreover, the 7 crystal systems along with their primitives and interfacial angles formed 14 Bravais lattices. Finally, conclusion. Here, the unit cell is the building block of the crystal structure and it explains the entire crystal structure and its symmetry with the atom positions along with its principal axis. The thermal, electrical, mechanical and optical properties of the crystals mainly depends upon the structural properties, and these structural properties could be studied with the help of X-ray diffraction methods and neutron diffraction methods. I hope all you understand the basic details behind the crystal structure. Thanks for watching.